right? The wheel is not changing. I still have 4 possible outcomes. That's me. Okay, but we're not going to multiply $1 and $1. So last class when we were working with area models, you have to multiply the fractions. So now we got to go back. Well, they already told me one of them. What fraction did they tell me? 1/8 is 100. So next to 100, I'm going to label that 1/8 on both sides of my area model. What's another easy one that you could figure out? What's $5? 1/4. Okay, so fill that in for $5. $10 would also be the same. And if $100 is 1/8, how much is $1? 3/8. Who said 3/8? Lovely. How'd you figure that out? How'd you know 3/8? Yeah, it's 1/2, right? So if this whole part is 1/2 and the $100 is 1/8, then how many more eighths do I need to make a half? 3/8, because the whole thing should be 4/8 or 1/2. Okay? So this would be 3/8. Okay? Great. Fill in the table. You got 2 minutes. Probability can really be written in 2 ways. You can use a fraction form. Be quiet. Or you can use, you okay? You can use a fraction form or you can use a percent. Okay? Mazel, am I keeping you from something really important? Fractions are okay to figure out how to multiply these because the pattern of the fraction that we use is okay, right? I multiply the 2 top numbers, I multiply the 2 bottom numbers. It's not so bad when we're dealing with fractions. However, let's start to look at some of the questions, right? So this is half of the state standard. I can create the model, right? So then let's start to look at some of the questions they're going to ask. So this is page 27 in your book, right, which you should have open right next to what you're working on. You're welcome. Question A says, what is the probability of winning $100? Well, first you got to go back. What did you have to do in order to win? Hit it 2 times in a row. So spin 1 and spin 2 had to be both $100. So now I can answer that question, what's the probability of winning $100? What is the fraction for when $100 meets $100? 1 out of 64. Not a problem. They asked me one question, I can pick the data off my table, and I'm done. Okay? Second question, however, gets a little bit more complicated and more of what a high school student should be able to accomplish. It says, what is the probability of winning anything at all? So what's the probability that I win $1 plus the probability that I win $5 plus the probability that I win $10 plus the probability that I win 100? So I got to go back and look at my table, right? What's the probability that I win $1? How much? This one here, right? 9 out of 64. What's the probability I win $5 is this one. $10. Get that thing out of your ear and I'll talk. So the probability that I win anything else at all would be 9 out of 64. Plus, you're writing this down, right? Because you know that I asked it and I'm going over it, so it seems like it would be significant. So that's the probability that I win $1 plus the probability that I win $5 plus the probability I win 10 plus the probability that I win 100. But for most of you, that means nothing. You have no concept. Maybe you slightly understand that 1/16 is maybe bigger than 1/64, but really you have no idea. So then I don't want you to use fractions. Because your high school standard is that you're going to have to understand the data and understand what it's talking about. And if you don't understand fractions, we're not going to use them. That would be silly. You cannot make justifications about things that you don't understand, and I'm not teaching fractions. There's a reason I don't teach 3rd grade. It's not where I want to be in my life, okay? So, side note, over here somewhere, I'm only going to say this one time and then fully expect that you know how to do it, okay? Fraction into percent. If you already know how to do it, great. If not, I'm going to say it one time and then fully expect that you know how to do it. So stick with me. Let's say I've got 9 out of 64. On my calculator, I'm going to do 9 divided by 64 and get something like this. Please stop yelling things out of your mouth. This is a decimal. If I want to take this and turn it into a percent, I then have to multiply by 100. So whatever my decimal answer was, I multiplied by 100. Now I have 14.06%. Okay, do I want 2 decimal places? Did I write them down? I sure do. Okay, so I want you to do that same set of steps for all 4 of these fractions, 0.06%. Okay, now be smart about it because 1/16 is going to be the same, so try and figure that out. Cents. 6.25. And that would be the same twice, right? And then what's 1/64? 1.56. Okay? All right, so then I want you to add them all up. So you should have one final percent. Okay? When you are doing these problems, you have a couple different options. You can put your percents up in the table if you have enough room, okay? If you don't, then you should always do this at the end. Because I know as somebody who's been in school as long as you have, you know the difference between a 14% on a test and a 1.5% on a test. You understand mathematically that 14% is more than 1%. But the fraction stuff, you're not going to be able to explain, well, I know this is a lot more, or whatever it is you need to explain in context of the problem if it's not in percents. So looking at this, 28.06%, okay, I forgot my things. Thanks, Mazla, 28.12%. Is that a lot? You think about it, you get that on a test? 28%? You really like, woohoo, 20. No, you don't know crap. Okay? So this model about things matching, what lottery games use this? Matching. Scratch-offs. Right? People are like, oh, I just need another. They're never there. They're never there. Their percentages of winning are somewhere down here, 1.56% or less. And yet you guys probably have family members, or you sometimes too, you're like, yes, yes, yeah, I won $1. That's great. You have spent $20 in scratch-offs and you now have won $1. Super exciting. Right? And was that our biggest percentage where the dollars met?
Yeah.
Yeah. Woohoo, woo, $1, yay. When I think it costs more than $1 to play.
It costs like $10.
So, depending on what scratch off you're using, okay? So, this right here, you can thank whoever's playing, because a lot of the lottery dollars in Oregon feed back into education in one form or another. So, you can thank them for helping to fund your education, but nobody's really winning a lot of money on the lottery. And this is why. People don't understand mathematically the percentages of the fact that you have to match it. Can you get that thing out of your ear? That's the second time I've asked you. I will cut it with scissors next time. Next problem. Flip the page to 29. Find this. 9-3, please. Okay, here's your question. So find 9-3. Marty and Jerry had just lost playing double spin. There's a big shock, because we just said their chances of winning were terrible. When they ran into another game that they had never heard of called Pick a Tile, in which the player reaches into 2 bags and chooses one square tile and one circular tile. The bag with the squares contains 3 yellow, 1 blue, and 2 red, and the bag with the circles has 1 yellow and 2 red circles. In order to win the game and a super exciting large stuffed animal, a player must choose 1 blue and 1 red circle. Okay? Oh, by the way, it also costs $2 to play. Of course, everything costs money. Okay? So, forget the rest of the directions. On your paper right here where it says 9-3, you can not do a tree diagram if you want, or if you really had a love for the tree diagram, you can do that. But I want you to just draw out the area model and what kind of choices would you have, right? There were 2 bags. So one bag's going to go up top and one bag's going to go here on the side. So you at your tables decide what you think your area model is going to look like. I'll give you a couple minutes to think about it and we'll go over before. My diagram is up on the board. Why is it not enough to answer any questions? I would need to turn them into fractions. So up on the top, I have 1 yellow and 2 red. So if I'm a math student and I get this problem, how do I turn that into a fraction? All it told me was 1 yellow and 2 red. So if I tell you in a bag there's 1 yellow and 2 red, how many do I have all together?
6.
3. So if one of them is yellow, what's my fraction? 1/3. And my 2 reds would be 2/3. My other bag has 3 yellow, 1 blue, and 2 red. How many altogether? 6. So this would be 3 out of 6, 1 out of 6, and 2 out of 6. You have to understand how to create the model. Because if you can't create the model, you're definitely not going to be able to understand the questions. Okay? That's one option. you could have also done a tree diagram. So let me show you what that would have looked like for some people, because you may think that that's easier. Okay? So bag 1 has 3, let's see, 2 bags. Bag 1 has 1 yellow and 2 red. Yellow circle, red circle, red circle. Okay? And then after that, you would have picked the next bag with 6 choices. So there would have been yellow, 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 blue, red, red. Yellow, 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 blue, red, red. Oops. Why would he have an eraser? What does it look like he's doing right now? Sitting around with an eraser?
No.
I don't have words. This, to me, if a tree diagram makes sense to you, fine. But this, to me, gets super complicated about how many choices you have. If you, however, have a better visual where you can lay out all of your choices, that's fine. And then count up. You're more than welcome to use a tree diagram. It is a legitimate, acceptable probability model. Many people use it. I taught it to you. You can use it. But for many of us, the spatial of trying to keep track of all this stuff is going to be better suited for an area model. So I'm going to go area model, but just know those of you that have tree models, you're absolutely fine. Okay? So let's finish this up. You should have all of these calculated and done. Okay, what's winning? Go back and look at your question. What gives you the most wonderful stuffed animal ever? 1 blue square and 1 red circle. Okay? So here's my blue square, right? These are my squares. Here's my blue square and a red circle. So really, I care about what's in this box. So what's my fraction that goes in this box? 2 out of 18. And when I change that to a percentage, I get 11.11. And for those of you with no conceptual understanding about what 2/8 means, other than that sounds small, please change it into a percent. Okay, so should they play the game? Okay, but here's the high school level question. It is going to ask you to read the problem, create the model, and then answer, should they play the game? So you have to be able to create this entire model, figure out which of the squares is winning, and then say, no, I think 11% is not that great for my $2. I don't really want to win. Maybe if I played it 5 times in a row, my chances are going to get greater. No! Your chances never change. That's the problem. You will be one of those people that takes your Social Security check and you'll be shuffling into there thinking maybe today is the day I hit the lottery. Your chances never change. Ever. I don't care how many times you play it. Your chances never are going to be better than 11%. So maybe if you were the hustler running the game, I would say you were slightly intelligent. But the suckers playing the game all over and over and over again, I don't have a lot of high hopes for. Great. Okay? Questions about this?
Nope.
Okay, because we time to fly. Here we go. Turn to page 30, where there's a guy shooting a basketball. One of my favorite names, Rimshot McGee. I call everybody in my house something McGee. Particularly Poops McGee, the littlest one. She stinks. Okay, last one. Next problem, basketball. Shooting one-on-one and free throws. So everybody should be looking at this problem in your book. And since it says 9-5, you should have found 9-5 on your worksheet. Okay. Rimshot McGee has a 70%, that's right, 70% free throw average. The opposing team is ahead by 1 point. Rimshot is at the foul line in a one-on-one situation with just seconds left in the game. A one-on-one situation means that the player shoots a free throw. If he makes the shot, he gets another one, but if he misses, you don't get another chance, okay? And each free throw is worth 1 point. Just those of you who are not basketball fans and you have no idea what we're talking about. Okay, first, on your paper, I want you to take a guess. What do you think is the most likely outcome? He's going to make 0 points, he's going to make 1 point, or he's going to make both of them. So right here on your paper, where it says guess, I want you to write is, do you think he's going to make 0 points, 1 point, or 2 points? Go ahead. He's a 70% free throw shooter. Seconds left in the game. Is he going to miss? Is he going to make 1? Or is he going to make 2? How many of you guessed 0 points? He's going to miss both? Really? That would have been my bet. 1 point? So first of the two, both points. Super great shooter. Okay, we'll see. We'll see. So just as a statistical analysis, most of the class thinks he's going to miss the second one but make the first one. So he'll make 1, okay? Just so you know.
Or miss the first one.
Okay, so what I want you to do, there is a model here that you can use if you would like. I would like you to come up with what is the probability for all 3 of those options. So you're going to either do a tree diagram or an area model. I don't care. What is the probability he's going to make 0? What's the probability he's going to make 1? And what's the probability he's going to make 2? You got 5 minutes in your groups. You can 49% for what? How many? 2 points? 1 point? 1 point. Not right. That's okay. It's not bad. You're the farthest along. Well, your diagram is good.
Wait, hold on. No, hold on.
So this is right if he gets 2 points, right? Because this is a make and a make. No, because 7 times 3 is 21.
Right.
Right.
Interesting conversation to listen to.
Let me be very clear. This is the kind of problem you're going to get. This problem does not have that many outcomes. This problem doesn't even have that much reading. It's free throws. And they told you how it goes. Either he makes it or he misses it. That's it. Okay? So I'm going to show you 2 models. I want you to be quiet and ask questions when appropriate. Model number 1. Let's say I want to do a tree diagram. Okay? And I haven't shown very many. Here's my choice. Rim shot is either going to make it, that's 0.7, right? Or he's going to miss it. So if make it was 0.7, miss it is how much? 0.3. Because they're going to total 1. Okay? Well, if I miss it, I'm totally done, right? So this would be 0 points, because it's not like, oh, rim shot, you're kind of cute, let's give you another one. Nope, nobody does that. So 0 points. That means 0 points is a 0.3 chance, or 30%, if you want to turn it into a percent, if that makes more sense to you. Okay? So after I make the first one, they give me the ball back. Well, rim shot. So then he could make the second one, which would also be 0.7, right? Or he could miss the second one, which would be 0.3. So if I'm looking for a make and a make, that's my 2 points, right? 0.7 times 0.7 is, you got a calculator, peeps, come on, 0.49, which is 49%. Okay? And then what if he makes the first one but misses the second one? So that's 1 point. That's 0.21. That's 21%. Okay? So those of you that said he was going to make both of them, you had the most accurate guess. Those of us that guessed 0 points, which was only me, I think, I was second accurate. And then the rest of you did not do so well. Guess-wise, right? That's why we don't go by guesses. That's why we create a model. Questions about this? Questions about where I got any of those numbers? Because this is a very appropriate C-level question. This is not what I consider to be hard. It might be hard right now, but it should not be hard by the end of the school year. Okay? All right, we're moving on to number 7. So find 9-7 looks like this. Find 9-7 on your paper. Bless you. Suppose that you were going to flip 3 coins, a penny, a nickel, and a dime. Make a sample space that shows all the possible outcomes. Recall that a sample space is a list of all the possible outcomes for this experiment. Okay? So just do that part first in your 9-7. So this is on last class when we were dealing with all those songs on Renee's MP3 player, and we did like A and B and A and C and A and D, and we just made a list. That's what you're going to do now. Okay? So on your paper, you got a penny, a nickel, and a dime. It's only 3 coins, and they only go heads or tails. List all your possible choices. Go to it. Heads, heads, heads would be one, right? That would be an example for those of you staring off into space. Have.
5.
I had 8, but that's cool. Okay, let's try this. It doesn't really matter which coin I've listed first, right? So this one could be my penny, this one could be my nickel, and this one could be my dime, all right, just for purposes. So I could get heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. So in this list, it does matter the order, right? Because each one of mine, it's not like Renee and her MP3 player where she was not repeating things. So this, for example, was tails on the nickel. This was tails on the dime. This was tails on the penny, okay? So keeping into consideration how many different options you have. Questions about anything that I wrote up there? Those of you that had 5 or 6, did you figure out which ones you were missing? Because you really need to have 8. All right, so now you've got your list. So now I want you to answer these questions here. So part C, where it says find the probability of each of the following events occurring. Be sure to show your thinking clearly. Well, that may or may not happen. But what I want you to do is right underneath your sample, you're going to do little I, and then little 2 I's, and then little 3, and then 4, and then 5, and then 6, because that's what those stand for in Roman numerals. And you're going to write me a probability using that sample space. Okay, there were 8 of them. Questions are in your book. So I'm looking at part C from your book for this question. You got a few minutes to answer your probabilities. Probability that you would get 3 heads. 1 out of 8. Very good. 8 choices. 1 out of them is 3 heads right there. Number 2, what's the probability that you would get at least 2 heads? 4 out of 8. This one, this one, this one, and this one. 4 out of 8, which you can leave as 4 out of 8, or you can write as 1/2. It does not matter to me. Number 3, what's the probability you get 1 head and 2 tails? 3 out of 8. 1 here, 1 here, 1 here. 3 out of 8. 1 head, 2 tails. Those of you that didn't even copy down the diagram, you're super lame. Number 4, at least 1 tail. 7 out of 8, right? This is the only one that doesn't have at least 1 tail. So almost all of them, 7 out of 8, would be at least 1 tail. V, or 5, exactly 2 tails. Well, this one has 2 tails. 1, 2, 3. 3 out of 8. And last one, at least 1 head and 1 tail. 6 out of 8. Very nice, because the only 2 that would not be included would be there, which you could also write as 3 out of 4. Questions about any of those? Amazing, because now you're going to do them on your own and nobody has questions. Okay, to hand in today before you leave. Circle this one, please. You're going to do 9-10. Okay, so circle that one. On the back, 9-11 and 9-12. 3 problems to hand in before you leave. 10, 11, and 12.